I'm going to change the tack slightly. I've got no slides, so be quite happy about that. So this year, we decided to have a session where we brought on a number of core vendors and researchers in RISC-V cores. There are an awful lot of core vendors and producers out there, and so we decided to give an opportunity for a number of those people, institutions, to come up and talk about their offerings, and I'm sure they'll tell you the good, bad, and the ugly, perhaps. And these people the companies and institutions do both commercial and open source cores. These cores, some of them will be written in Verilog, some will be written in using high-level synthesis or other languages. The cores range from low compute microcontroller type cores to high-end multi-issue machines. These cores will run bare metal to rich operating systems, including Linux. The application of these cores will go from IoT through to servers, to automotive, but I'm sure they'll tell you very shortly. The running order is that each institution, company will have 5 minutes, so it's like a speed dating thing. And then I shall be lurking in the corner, and I will raise my finger, this finger, not the other one, when it's 1 minute to go. We have a number of people to come up, and when they've finished, assuming we have some time for Q&A, you guys out there can ask them some difficult questions, and hopefully they'll be able to answer them. But before we do that, we have somebody who's been doing a lot of research in investment and the AI space, and so we'll hear a talk from them. We have, just quickly to mention who they are, we have representations from Tractica, Andes, Codasip, Shakti project from the IIT Madras. We have OpenHW group, somebody from SiFive, Syntacore, and then Western Digital again. Oh, sorry, it'll be Next Generation Chips Alliance, I apologize. To start with, can I call Anand, Joshi up to stage, please? So 5 minutes, 1 minute, okay?
Hi, my name is Anand. I'm a market analyst with Tractica, and I follow AI chipsets primarily. I did a report on RISC-V last year, as this is one of the areas that's been growing, and that caught my attention, and so did the company's attention. And I just want to give you a few minutes of overview on the RISC-V market, how things are going, how they're evolving, and where do I see the road going from here. So the way I did research is that we essentially try to put together a comprehensive 360-degree view of the market. So I conduct interviews with vendors, users, third parties, the ecosystem providers, and of course the neutral observers, the people who are investing. And based on that, the general consensus was that the growth is above 50% for the last 2 years. So the market for 18 and 19 was relatively small. So the market actually is going to hit 1 billion mark based on my projections today. And there are 4 components. There is the licensing, there is the royalty, there is support, and then there is software and tools. Licensing component is big right now. Royalty component is very, very small. The support component is also big because there is a lot of companies providing supports based on the cores that are downloaded from the internet. And then software and tools are again small because not many companies are shipping. So that is going to take some time. But overall, the growth is very, very healthy. And the CAGR is like 50%. Obviously, it doesn't keep up. It stays like that in the beginning, and eventually it will taper down. So what is driving this market? First of all, RISC-V is open source. They have very generous licensing terms. So that opens up a space for a lot of vendors who can take that and customize it and then sell it to anybody who's building SoC. So that's why you see a lot of vendors, and we have a series of presentations after these who are going to be presenting about their chipsets. The evolving algorithms, in particular AI, has been very, very beneficial to RISC-V. The reason being, ARMs and MIPS and all the traditional IP guys that are out there, they have somewhat restricted instruction set. So when RISC-V ISA was open sourced and freedom was given to people to do whatever they wanted, the AI community actually welcomed that, because AI world is moving so fast that the networks that were developed 5 years ago are already extinct. They already moved on to new ones, and with new ones, new operators are introduced and new mathematical problems come up, and so you almost have to keep up with the AI world in terms of instruction set. There is an increasing need of processors per SoC. So obviously ARM is big, and the A series and application processor that's been thrown out there. So there is a lot of reluctance from SoC guys to switch from ARM A series to something else. But everything else on that SoC, Ethernet or serial communication, all of that, they could easily do that with RISC-V, and there is a lot of traction for RISC-V. Some of the vendors I spoke to, they said they decided to go RISC-V route because they just couldn't do ARM-based architecture because their competition was doing the same thing. So they said, we'll take different approach. They will customize it. They'll make it very low power. They'll take out anything that's needed. And the need for differentiation was actually one of the reasons why they chose RISC-V. And then obviously, when Google and Western Digital, Micron and Samsung, all they say that they're going to be shipping RISC-V cores, that helps, and people tend to jump on that bandwagon. But obviously, the road is not without challenges. The ARM wall is there. ARM is the 80-pound, 200-pound gorilla in this market. And most of the design starts today, other than few startups, are using RISC-V as secondary processor. And so we'll have to wait and see how this particular situation evolves, and when RISC-V actually becomes an application processor as opposed to a secondary processor. Ecosystem, long ways to go before it can mature like ARM. And so we'll have to watch that space very carefully to see how that evolves and how actually it becomes easy to design RISC-V-based SoC. Switching costs, some people said that because they had people trained in Tensilica or ARC, they didn't want to learn something new from scratch. So there may be some resistance in different companies who are actually invested into one particular architecture. And then some people said that because RISC-V is new, there aren't that many people who know all these things, and it will be hard for them to switch. This is a short summary, and I can see that my time is 1.5 minutes left. So I'll be brief here. So the markets where RISC-V is selling today is really storage, communication, computers. Again, they're all driven by big companies like NVIDIA's and Western Digital. But AI is one where there's a lot of startup activity, and Esperanto and a bunch of other companies are actually, Greenwave, they're actually shipping. Greenwave is shipping, Esperanto is not, but a lot of activity, a lot of designs are coming to conclusions. So that's a very interesting space for RISC-V to be playing into. Internet of Things, these are ultra low power chipsets. The Chinese company Huami, which is really the IoT company of Xiaomi, they are shipping their wearable based on RISC-V. So again, a lot of shipment there, but again, ultra low power kind of application. And there are a lot of evolving areas for the market. No clear trends just yet. We'll just have to wait and see how that market evolves. And so with that, just a quick 30-second summary on where do I see things going from here. And so RISC-V definitely is going to be a good secondary processor. There is going to be a time before it becomes application processor, and there is a lot of hurdles that need to be overcome. The market growth, and the reason it's only 1 billion in 8 years as opposed to 5 billion is because do customers really want to buy a cheap or open source RISC-V that works, or do they actually want to pay this as a product? So there is some question mark there, and the way things are going, it seems to me that there is going to be a Linux-like business model. In the sense that people would probably go and download the RISC-V that's open source, and then they'll pay some third party to essentially support and maintain it. So there is a lot of money to be made in support and services around this. The licensing royalty, the way it stands today, is very, very low in comparison with even Tensilica and ARC. So again, we'll have to watch that, how that evolves. But nevertheless, the times are very exciting. The IP market dynamics are evolving every day. At least one prominent player, from what I know, is going to be shutting down, or there is a rumor out there. And then the whole ecosystem and standardization, how the corporate entities play, all of them is going into play. And it's exciting road ahead. So with that, I'll stop and pass it on to the next speaker.
Thank you very much, Anand. Next up is Chen from Andy's.
Hello, everyone. I'm Chen from Andy's Technology. Today, I'd like to introduce our processor solution, which covers from edge device to cloud. So let me give you a brief introduction on Andy's technology. So we are a 14-year veteran CPU IP company, and we went public in 2017. And now there are more than 1 billion Andy's embedded SoCs shipped every year, and we have more than 180 commercial licenses. And actually, all our core development founding team are actually from Silicon Valley, from major CPU and GPU companies like AMD, DEC, Intel, NVIDIA, Sun, and so on. And we are a RISC-V founding member and a major contributor on things like GNU, LLVM, U-boot, glibc, and so on, Linux. And also we are chairing and co-chairing technical task groups. So currently our RISC-V customer actually has a wide variety of range, which covers from the IoT edge device, personal, up to cloud data servers. And about 50% of them actually use AI, using AI application. So here's a quick overlook of our processor lineup. From the bottom, we have a small and fast processor, which also has an option of a floating point unit or DSP unit. And then you can also have a Linux MMU that can allow you to run Linux. And you can have like cache coherent multi-core configurations. And they all come with either 32 or 64-bit flavor. So you can pick and choose from which one best fits your need. And 2 days ago, this week, we just announced our new 27 series, which supports vector instruction, the RISC-V vector instruction. So it's good for like heavy computational applications. Additionally, we also announced 2 days ago our 45 series, which has a superscalar capability. So it will offer higher performance for our customers. Also note that all these cores actually comes with a great feature. We call that Andy's custom extension ACE, which allows you to create your own instruction. And note that we are also the first RISC-V company to support P extension. So what is P extension? RVP. P extension is actually SIMD, like DSP instruction that for small cores that use existing integer register file. So you don't need extra register file, you use existing register file. So for example, you can do 4 8x8 multiplication and accumulate in one cycle. And if you have a 64-bit, you can do 2 of them in one cycle. So this is great for like applications like audio. You can get 2 to 3 times faster in audio application. Also, they are great for AI, artificial intelligence applications. So you can gain from 5 to 14 times faster, for example, like face recognition and so on. And so let me talk about ACE. So we allow you to create your own instruction. We give you a tool to automatically generate the RTL for you, the Verilog RTL, generate the simulator, and also generate the tool chain for you. So it's very easy to create your own custom instruction to best fit your algorithm, your computation. And we cover a wide range of operations like vector, non-vector, like background, and so on. Interestingly, we noticed that ARM recently announced like they also give some customer to introduce their own instruction. So I'd like to thank ARM for finally recognizing the importance of creating custom instruction, but it's just too little. It only covers the basic type. So if you are interested in any of the in my topic. At 4:10 this afternoon, like 2 hours, 1.5 hour from now, our CTO Charlie Su will have a more in-depth coverage on all of them. And also we have a booth in the expo area, so you are more than welcome to stop and let us know. Yeah, thank you.
Thank you very much, Kevin. Yeah, so next up is Karel Masarik, from CEO of Codasip.
Hi, everybody. Well, let's start with speed dating. So, short introduction of our company. Our company was founded 2014. It was actually in Czech Republic, based on the university research. For 10 years, we were focusing on the methodology, how to design in an efficient way CPUs, not just RISC-V, but also VLIW. We are the founding member of RISC-V Foundation, and we are growing. So our headquarters is in Munich, in Germany. We have offices in Czech Republic, Silicon Valley, and in China. And just briefly, our product offering basically, as mentioned, started with EDA tool for microprocessor design, and we easily extended it to RISC-V. So we do provide customizable, fully extendable processors, starting from, let's say, low complexity to high complexity. And it is possible because, let's say, we are using a high-level description language, much higher than Chisel, from which you can easily, let's say, generate everything what you need for let's say, your SoC. Basically, we are missing in our portfolio several, let's say, processors, which fortunately Western Digital is designing, and we started this partnership with Western Digital. So would like to introduce SiFive support package. And basically, Zvonimir was talking about SiFive already, so I do not need to introduce it. What is important, let's say, for SiFive users is not just RTL, because it's starting with RTL, but let's say for easy integration, you always need something more. So basically, SSP, it stands for SiFive Support Package. The first availability should be mid of Q1 next year. And we have a very flexible engagement model. This package should contain a set useful tools for programming of SiFive, sample deliverables, and technical support, which is very important, let's say, in early stage of adoption of new SiFive cores. So you can get more information at our web pages or visit our booth when we can provide more information. As said, the main reason is that RTL is just, let's say, piece of the puzzle, and basically it is not so easy, let's say, to publish implementation of third-party tools like verification test benches, synthesis scripts, or let's say, integration to virtual platforms. And as said, usually customers, what is our experience, need to have some sort of assistance on daily basis. So for this purpose, Codasip is here for SiFive users. So our package consists of 3 parts. So first one is hardware. It is the recent release of the SiFive cores, of SiFive core at this moment. As Zvonimir mentioned, new cores will come very soon. So we are working closely, let's say, on, let's say, give you the really recent update of the SiFive, including, let's say, what is necessary. As a synthesis script, FPGA bitstream, benchmark, and documentation. For verification, it is important to have verification reports with coverage data. We will provide you referent test bench, system verilog assertion monitors, verification IP. And the last piece of the package is software part, which consists of GCC compiler toolchain. Basically, it contains NewLib, binutils, GDB for easy debugging, then Eclipse IDE, which is a graphical interface for debugging and for profiling, and for sure abstraction layer, for example, with OpenCD for JTAG connectivity. So it was really a short overview, and you are welcome, let's say, to get more information after this session or at our booth. And we're looking forward for more users of our or Western Digital course. Thank you very much.
Thank you, Karel. Next up is Arjun Menon, who's a senior project manager in the Shakti project at one of the more prestigious universities, IIT Madras.
Thank you. Hi. So Shakti is a processor ecosystem effort from IIT Madras in India. So we do not just design processor cores, but we also design peripherals, SoCs, verification frameworks, and SDKs, IDEs, and so on, right? But for this talk, we'll mostly be looking at the cores that we design. So we have three classes of processors called the E, C, and I class. The E and C class are production grade, and they are completely open sourced. The I class is still in late stages of verification, and that's something which we'll not be covering in this talk. So all our cores are designed using BlueSpec System Verilog, which is an HLS. The very first core that we have is the E class, which is a 3-stage in-order processor. It can boot FreeRTOS and Zephyr. But more interestingly, what it can also do is you can configure this to be a 32 or a 64-bit core just by changing a single line in the configuration file. You can also have the atomic C and M extensions also just by changing the config string, right? These are the numbers on the FPGA and ASIC implementations that we have done. Also, you can find the source code in this particular link. Moving on, we have the C class core, which is a slightly more performant code compared to the E class. It's a 5-stage in-order core, and it also has support for the supervisor and user level, and also the N, which is the which is the interrupt ISA. You also have a branch predictor and an RAS, and the performance is about 1.72 DMIPS per megahertz, and it's capable of booting the Linux kernel, right? The C class core is also as configurable as the other cores. You can choose which ISA subset you want to, and the RTL would get generated only for that particular subset. We have done 2 prototype tapeouts for the C class, one on the 180 nanometer fab in India, which is called SEL, and another one was sponsored by Intel on their 22 nanometer process. Again, these are the FPGA and ASIC numbers, and you can download the source code again at this particular link. Moving on, the most important part or the key thing about Shakti is that everything is configurable, right? So you have the ISA, which is completely configurable. You also have caches in which you can configure the number of sets, ways, banks, and whatnot. You have branch predictors, which are again configurable, MMU, and you can configure the PMP sizes, the number of performance counters you want, what do you want to count, etc. And we also support various simulation platforms like Verilator, VCS, and so on. Right. So we are also developing a multi-core version of C class, and this is in collaboration with Thales, where we are looking at a multi-core version of the C class, and where you can configure the number of cores from 1 to 32. And we have a tiling C bus protocol, a directory-based MSI cache coherence, and also an NOC with mesh topology. But most importantly, what we have is a criticality-aware NOC, which means that the packets that go in the NOC have a notion of criticality. You can say that some packets are highly critical, some are low. And we can provide time guarantees on the highly critical packets that travel through the NOC, which are really important to Thales, which is an avionics company. We also have uncore IPs like bus protocols, Axie4 Lite. We have bridges that convert from these various protocols. We also have the POSIT arithmetic units and some other extra peripherals. So I think the peripherals are not all listed properly, but yeah. So finally, what do we have as offerings, right? So we have the core and uncore IPs, which we had just looked at. But additionally, we also have verification frameworks like CocoDB. We have an automatic assembly program generator, a trace analyzer, and so on. We also have a good software ecosystem where we provide you with an IDE, SDK, and we are also working on porting RISC-V OCaml, on porting OCaml to RISC-V, and also the Mirage operating system. Finally, we also do a couple of research projects where we are looking at AI, ML, and crypto accelerators, and also some extensions for security. So to conclude, the best thing about Shakti is that it's not just free, it's BSD license, which means you're free to download, modify, and use it however you want to. There's no royalties, there's nothing involved. So start using Shakti today. Thank you.
Thank you very much, Arjun. Next up is Drew from SiFive.
So my name is Drew Barbier. I'm a senior product marketing manager at SiFive, responsible for the RISC-V IP portfolio. So this is the landing page for our website, Silicon at the Speed of Software. So think about that for a minute. If I'm a software developer and I'm starting to build a software developer environment in the cloud, how long does that take? Minutes? Usually if you're using something like Amazon AWS, you would log into your account. You would select the type of compute resources you need, so the types of CPUs, the number of CPUs, how much RAM, how much storage. Maybe also pick the OS, maybe also pick a software stack to start from. And that's it. At that point, your environment's deployed in a few minutes and you're ready to go and start developing. Now contrast that with the hardware world. Can you even get an EDA license in minutes? How long does it take to actually license third-party IP and integrate that into your solution? Right? So at SiFive, these are the types of problems that we're trying to solve. And we're using web technologies and web technologies and creative methodologies to lay the foundation for the future of hardware development. And that all starts with the most fundamental piece of IP, the processor. So at SiFive, we were founded by the inventors of RISC-V, and we have a unique portfolio of highly configurable RISC-V processor IP that I'll talk about now. So this is the product map. It's growing pretty large, and a couple new announcements that we made today will make this grow even larger. So the way we partition our product portfolio is in sort of a 2D matrix here. So we have E, S, and U cores, with E cores being the 32-bit embedded products, S cores being the 64-bit embedded products, and then U cores being the 64-bit application class processors. These implement RISC-V supervisor mode and by extension support high-level operating systems like Linux. Then we have a number of core series, and the series dictates the microarchitectural implementation. So we have the 2 series, which is our 2 to 3 stage most efficient implementation in our portfolio. And within the 2 series, we have both a 32-bit E2 implementation as well as a 64-bit S2 implementation. So the 2 series I mentioned was our most efficient. It's a microcontroller class core and oftentimes the entry point into the SiFive product family and portfolio. Then we have the 3 and 5 series. So these are 5 to 6 stage pipeline processors in order issuing, so still very efficient. But they tend to implement, or we start to introduce more advanced features. So things like optional caches on the instruction and data side, multi-core capabilities, level 2 caching, things like that. And within the 3 and 5 series, we have the E3, the S5, and the U5 core. So the E3 was the first commercially available RISC-V processor. So this was available on SiFive's Hi5 1 board that we launched back in 2016. We've also since then realized both the U5 and the S5 into silicon in the Hi5 Anlayst development board. Both of these boards you can see at our booth in the expo hall. Last year, we announced at the Lindley Fall Conference the 7 series processor. So this is our dual issue 8-stage pipeline. So it's very high performance, but still efficient as well. And then within the 7 series, we again have the E, S, and U implementations. In addition to the increased performance and the dual issue capabilities of the pipeline, we also spent a lot of time in the 7 series on the memory subsystem. So increasing both the latencies and bandwidth through to memories, the amount of configurability in both the level 1 and level 2 memory systems. And then finally, in the Lindley Fall conference this year, we announced the 8 series product, which is our triple issue 12-stage out-of-order processor. So this is going to be our highest-end flagship processor for future high-end applications. But at SiFive, we do more than just processor IP. We also have a complete portfolio of debug IP as well. And it's a scalable solution to match the scalability of our portfolio. So we have basic debug control, whereby you can do single step, set breakpoints, do debug over JTAG and CJTAG and so on. We also have SBA or system bus access, so you don't have to halt the core to do accesses to the bus through the debug unit. We support multi-core debug. We support trace as well using Nexus Trace, so we can trace across our entire portfolio. We also have secure debug as well, so you can do things like debug authentication. We also have a open and scalable security platform, which Danny introduced yesterday in SiFive Shield. This is a system-wide security solution that's really bottom to top. So it has root of trust IP in it. We also have crypto engines for protecting against things like side channel attacks, operating system support, so software availability in order to be able to interact with the hardware IP that we have. We also have things like TLS for secure communications, secure lifecycle as well, so you can manage the lifecycle of your product from inception to end of life. And all of this is brought to you over a product we call SiFive Core Designer. So I mentioned our IP was highly configurable. The way you configure your IP is done through a web portal. So all of the configuration options of the processors are available in SiFive Core Designer, be it selecting how many cores you want, how many, the configurations of the L1 and L2 memories, debug, security, and so on. And so through SiFive Core Designer, you would configure your IP, and what gets delivered to you is the exact Verilog RTL of your implementation that you define, along with all the supporting collateral necessary to realize that design. This includes things like documentation, which is specific to the design, specific BSPs, as well as FPGA implementation so that your software teams can try the new configuration instantly. So we're demoing SiFive Core Designer at our booth in the expo, so please do stop by. And then finally, it doesn't stop at hardware. We also have software solutions as well. So because our IP is so configurable, it also requires configurable software. And so we have a number of different software products that we offer. So Freedom Tools is really just a collection of open source tooling, things like GCC, GDB, QEMU, and other scripts and utilities that we've created to support our SDKs. In addition to having the open source repo available, we also regularly produce binary distributions of our tools. Freedom Metal would be our portable bare metal library that we use to provide portability across software solutions across our IP solutions. And then Freedom SDK is the SDK in which you would actually write and program your software. In the SDK, we include a lot of makefiles and utilities and things like that, as well as many examples, and one new feature is free RTOS as well in Freedom SDK. And then finally, Freedom Studio is an Eclipse IDE where we wrap all of these software tools together in one single easy-to-use package with a GUI debugger that you can use to do your entire software development flow. That's all I have. So we are demoing a lot of this at our booth, so I would encourage you to stop by. Thank you.
Thank you, Drew. So I'm hoping we've applied some ECC now, and so same person, hopefully you recognize him again. It's President, CEO, and founder of OpenHW, Rick O'Connor.
We'll try this again. We had a cache mismatch. Took a little while to load again, and so here we are. So this morning, during my talk, if you were in it, I started to talk a little bit about the Core 5 chassis and what that concept is. We announced this yesterday at the beginning of the summit. The Open Hardware Group is a nonprofit organization stood up primarily to, initially anyway, support the good work out of the Pulp platform team at ETH Zurich, Luca Benini's team, specifically around the Ariane core and the RISC-V core, which are being brought into this organization under the Core 5 banner. So the CV64A is the Ariane, if you're familiar with that, and the CV32 is the RISC-V core. We kind of stood up a project yesterday, or announced it, around a concept called Core 5 chassis, where we will hopefully use this chassis, not hopefully, the plan is to use this SoC chassis, which is based on NXP's very, very popular and successful IMX platform. We'll reuse this chassis over the next 2 to 3 years and drop in different core complexes in as the processor complex, starting initially with a single 64-bit core and a single 32-bit core as a coprocessor, followed by multi-core configurations, vector processors, and so on. I should point out, I'll go back, because I've got this question many, many times. So is this an open source IMX processor? No. The good folks at NXP are providing the chassis so that we have a real SoC system to prove these cores out in. We will be building these SoCs in a deep submicron flow. We haven't announced that yet, which one it'll be. These SoCs will be available on eval boards. This is not a production product, but we'll be producing up to potentially 10,000 of these eval boards, making them available in the developer community so that folks who are interested in integrating these particular open source processor cores can evaluate them in real silicon and participate in that work. So part of the work that we're doing within the Open Hardware Group is to validate these cores and these designs for use in high volume production SoCs. That's part of the reason for taking it right through to silicon. So if you're not familiar with the Ariane core, it's a very popular core out of the Pulp platform team that we're dubbing the CV64A. It's a 6-stage in order processor and has been optimized for performance. I think these numbers came out of GF's 22FDX flow. So running the core at 1.5 gigahertz, it's quite a nice performing core. The RISC-V core is what the Pulp team would tell you is their workhorse core. Both of these cores have seen silicon many times from the Pulp platform team. This device in particular has been probably put into at least a dozen or more different projects from ETH Zurich. It's a IMMF with some ex-Pulp custom extensions and has been used, like I said, in many different projects inside ETH Zurich, as well as a bunch of industry uses as well. So this is the ecosystem that we're building around doing this. The verification environment is obviously the biggest nut to crack, and it's an open collaborative verification environment. We're running this on real system Verilog simulators, in particular a cloud-based simulator from Metrics. And all of the scripts, the synthesis scripts that we use for these cores, the verification stimulus and so on, all of that is open source and available that you can either participate in the cloud-based environment that we have or take all of that stuff and use it in your own simulation environment. So a couple of examples of what we might do next. So this is actually a project called Hero at the Pulp platform team. Multiple 32-bit cores clustered as accelerators controlled by a 64-bit core. And then here's the ERA vector processor that's being worked on by the ETH team, again controlled by a host, Ariane. And I'm happy to talk more about this at our booth in the exhibit floor if you want to talk some more. And would welcome you to come and join us and participate. This is a fun program. Thank you.
Thank you, Rick. So next up is Senior Director and co-founder of Syntacore, Alexander Redkin.
Hello, everybody. My name is Alexander, and I'm going to briefly describe you what we do in Syntacore. So, a bit of history of the company for those of you who are new to the RISC-V events. We are IP company. We are founding member of RISC-V Foundation, established back in 2015. Currently at 40 employees, headquartered at Cyprus, with R&D offices in Russia, main office in St. Petersburg, with smaller one in Moscow. As a company, we focus on two things. First, we develop and license state-of-the-art RISC-V compatible CPU IP. Majority of our product line, which I will show in the next foils, is already silicon proven at the customers and ships in full wafer production in some cases. And this is, and we've been doing that for a while. So we have more than 4 years of focused RISC-V only development. And before that, core team which established that company comes from more than 10 years of highly relevant background. So we've been working on CPU technologies in a major multinational company before that company. All our IP comes with full expected collateral, which means SDKs, samples in silicon, specifications, full synthesis and simulation, harness, etc. Software stacks as well. This is one aspect of what we do, and second part is we provide full one-stop customization service based on our IP. We can do that in different forms. We can take complete and defined by the customer specification, or can start from the workload and design ISA extension for the customer. And we do that as a one-stop service, including compiler, toolchain, and software layer optimization if needs to be. Besides of that, we provide more traditional services as IP hardening on the required library node, and SoC integration and software-related services. So this is how our product line looks currently. Overall, we have 8 cores in production. 5 of those are microcontroller class, and 3 are Linux capable. I'm not going in full details currently about this. We have a booth at the exhibition floor, and we'll be more than happy to provide you full details about this. There is, product briefs, etc., some nice demos too. But I'm just going to highlight a couple of cores later in the talk. And here are features. We think they are comprehensive and state-of-the-art. So just to name few interesting ones, our cores can be deployed together in heterogeneous manner, including full OS capable cores and embedded, like microcontroller, real-time operating system ones. And what we want to specifically highlight, all our designs are very traditional, very, very compatible with traditional EDA flows, clean slate designs in system Verilog. So I'd like to highlight a couple of cores. First of all, it's CR1. This is industry-grade microcontroller class core, which have been open sourced for more than 2 years. It's basic design, but it's highly useful and very used. One of the top System Verilog repositories in the world. At GitHub, it's distributed under SHL license, which is basically Apache 2.0 derivative, and have been used in multiple companies, including full wafer production. So we provide customization and support services based on that. Another design which I want to highlight is our SR7 design, which is out of order dual issue machine. We think it's highly competitive for the space, and we are one of probably few companies you can get such a RISC-V based design currently on. It supports up to octa-core configurations currently, and has many comprehensive features. So if you're interested in that, please stop by. We do provide full collateral, including tool chain and everything, and this is our baseline. Besides of that, we collaborate with majority of tool chain vendors which work in the ecosystem. We have some demos of that at the XGBit. With that, I'd like to conclude. Thank you. Please stop by our booth for more details.
Thank you, Alexander.